All right, so our next type of exponential growth equation has to do with compound interest. The last few equations, they dealt with interest, but it wasn't compounded interest. So compounded interest occurs when the interest is calculated on the principal, like the initial amount that you put in, and it's also the interest is taken on the amount that is accrued over a period of time. So, for example, say you put in $100 into a savings account, and just for the sake of ease, let's say it increases at 10%. Let's say every month. So after the first month, you get 10% of 100, which is 10. You get that added to your account, so you have $110 after 1 month. And then the next month, it compounds again. And then you take 10% of what you have in that account, which is, what is that, like $11? Then you add that to this new balance, right? So every month you have a new balance. And then the interest gets added on to that month. So then here you would have, 121. And this would happen on a monthly basis, depending on when it's compounded. And so let me just tell you the formula. So the formula is dang dog, throwing sticks at my camera. A equals P times 1 plus R over N to the N times T power. So P is your principal. Which is really just your initial amount that you started with. And principal is the word that is used when you take out a loan at a bank. If you want to buy a house, you could put down, say, $20,000 to buy your house. Well, you would put down an amount, that principal amount. Principal is just basically what you started with. R still equals rate. And so your rate is like the percent of increase. And then N is like the number of times compounded in years. So let's take it to this example. If it got compounded monthly, well then over a year, stop it. Over a year, you have 12 months. Over a year, you have 12 months. And if it got compounded monthly, then N would equal 12 over a year. And so N is the number of times that it's compounded. T is still the amount of time. And so, okay, let's start with this example. So Laura deposited $1,200 into an account that earns 8% interest. And so she started with this amount, which means that your principal, your starting amount, is going to be $12,000. Your rate is going to be 8%. I'm turning it into a decimal. And let's see, how much money will she have in 5 years if the interest is compounded quarterly? So there's a bunch of words here that we need to know what it means. Like monthly, I think everybody gets. Monthly means it's compounded 12 times in a year. Quarterly means 4 times in a year. 4 times in a year. And so for that reason, N, the amount of compoundings, is 4, because the number of times it's compounded in a year would be 4 times. And so our amount of time that we want to look at is 5 years, right? So T is 5. And so basically we can find A, which is the final value, like your current value that you have after 5 years. A is going to equal P, what she started with, 12,000, times 1 plus R, which is 0.08, divided by the amount of times that it's compounded, 4. And we figured that out because this word quarterly. And all that's going to be raised to the, well, what's n? N times t. So n is 4. T is 5. To the 4 times 5. And so, well, that's just 20. And if I type all this into my calculator, I'll get that the amount she has after that period of time is $17,831.37. So after 5 years, her interest gets compounded 4 times in a year. And after 5 years, she'll have this much quarterly. And it's important to write this down. Quarterly is 4 times in a year. Okay, next. Jack took out a 6-year loan for $25,000 to purchase a boat at, this is the interest rate. And so if the interest is compounded monthly means in a year, it's going to be compounded 12 times. What will he have paid over the course of the loan? So in this case, Laura, she deposited money. She got this money, right? That's what she has in her account. Well, Jack here, he took out a loan, but the interest on that loan is going to be compounded every month. And so the question is, well, how much is he going to pay overall, you know, when the time is up, when the 6-year loan is up? And so we're still using this same formula, plus R over N to the N times T power. We don't know what the final amount is, right? They didn't give that to us. But the principal is the initial amount. So this is the initial amount. This is like the purchase amount that he paid for his boat. So P here equals 25,000. And so here I'll just write that in. 25,000. 1 plus R. Well, what's R? I'm going to turn this into a decimal. R is 0.045. So R, 0.045 over N. N is the amount of times it's compounded, and if it's compounded monthly, that's 12. So over 12 times N, or to the NT power, that's 12 times T. T is in years, so 12 times 6. This is pretty standard for, like, if you're going to take out a loan on a car. I mean, 4.5% interest is pretty low, actually. And depending on your credit, it would probably be a lot higher than this. It could be that amount, depending on your credit. But, you know, you would think you wouldn't pay too much more for a $25,000 boat. But once you type this in your calculator, you'll see this dude, Jack, he ends up paying $32,732.58. That's what he'll end up paying over a 6-month course. And so, let's see. Yeah, so basically that's it. Now, there might be different questions where they actually give you the value of A. Like, take a look at 8, for example. A savings account offers 8% interest, or 0.8% interest, compounded bi-monthly. Bi-monthly. So bi-monthly means twice a month. There's 12 months in a year. Twice a month for every month. That would be 24. So N here equals 24. I'll write it here. N equals 24. The rate, I'm going to turn that into a decimal. 0.00, what is that? 0.008. Okay. If Bob deposited $300 into this account, how much interest will he earn after 10 years? And so, how much interest? And so, they're really just asking, what is the interest that he's going to earn? I guess this one's a little different only because we have to subtract the value. So I was wrong in saying that they're going to give us the A value. Some problems are like that, but let's see. Annually, what will be the about? Yeah, maybe none of these problems are like that. Suppose an investment account compounded weekly. How much will he earn after? Yeah, never mind. So anyways, this problem's a little different, so let's do it. Let's see. He deposited 300. So P equals 300. That's the initial amount, right? How much interest will he earn after 10 years? Time is 10. T is in years here. And so, okay, the amount equals the initial times 1 plus R. R is 0.008 over the amount of compoundings, N, which is 24, to the N times T power. So 24 times T, T is 10, right? And so when you type that into your calculator, you will find that, let's see, what is this? Well, this is, total amount is $324.98, but that's not our answer. This is the amount that he's going to have after 10 years, but the question's asking, well, how much interest will he have earned? Well, if he started with 300 and now he's at 324.98, then that means that the amount of interest he earned is 300 or 324.98 minus 300. So he actually earned $24.98 interest. Not that much at all. Anyways, you'll find your homework assignment. It's just 5 problems. Hey, tomorrow we're going to have a quiz. And it's going to cover everything that we've learned during the e-learning time here, or this past week. And we're basically done with this unit. And so next week we'll have a test, but we're going to have a couple review days, okay? And so you'll find the homework for this assignment attached. And okay, bye-bye.